Hello everyone, welcome to another TBC Power Hour. Today we're talking about tunnel surveying, my personal favorite topic, and myself, I'm taking over the TBC Power Hour again, of course, to talk about tunneling. So excited to be here. And just a few items to start, some housekeeping items. So if at any point you can't hear any of the presenters or you can't see the screen or any technical difficulties like that, there is a little chat question window in the GoToWebinar panel. So just go in there, type it in, and let us know if you're having any issues, and we'll try to take care of that as we go. Likewise, if you have any questions or comments throughout the whole webinar, and we want to ask either Nicole or myself any questions, feel free to type those in there, and we'll answer those as we go. And end of those. Also, this is going to be recorded, so probably in 1 or 2 days you'll receive an email follow-up with the recording of this presentation. So if you want to view it again at a later point, or you want to share it with a colleague, by all means you'll be able to do that. We also put all webinar recordings up on the Trimble Geospatial webinar site, so you can access them there. Additionally, in the handouts tab of this GoToWebinar panel, there is a PDF file which shows that has all the webinar slides there. So if you want to reference those at any point, you can download that PDF and have that on hand. And aside from that, I think that hits all of the housekeeping items, and we'll dive right into it. So it'll be around 1 hour webinar, just for all of you for awareness. All right, so today presenting, we have myself on the right-hand side, Riley Smith. I'm Product Marketing Manager for our monitoring and tunneling groups in Trimble Geospatial. I'm based in Westminster, Colorado in the US, and there's my email there if any of you want to reach out to me. And then today I'm joined by Nicole. Nicole, do you want to introduce yourself?
Yeah, for sure. Thanks, Riley. So, hi everyone. My name is Nicole Lim, and I'm a software QA testing intern for the Trimble Business Center team. I'm currently studying geomatics engineering at the University of Calgary here in Canada, and over the last few months, I've been testing the new tunnel convergence commands, which I'll be demoing today. So, excited for that.
Excellent. I'm excited to have Nicole. She really is the expert on the convergence workflow in TBC, so it's going to be an awesome webinar. All right, so what are we going to cover today? So first, we're going to talk about what is convergence and convergence monitoring. Some of you on the call might already be familiar with this. Maybe that's why you're attending the webinar. But if not, we're going to dive into what it is, why that's important on a tunnel or an underground mine project, and then also some methods of how you can capture that convergence data. And then we're going to get into a convergence workflow, primarily focusing around how you would collect that with a robotic total station using Trimble Access software in the field and TBC in the office. And the majority of this webinar will be covering a demonstration of how you actually capture that data and then process it in Trimble Business Center and get out your monitoring reports. And of course, we'll have some time at the end of the presentation to cover the resources and some next steps for all of you in case you want to find out more. And of course, some time to cover questions and answers. So with that, I'm just going to take a look to see if any questions have popped up or any comments so far. And it doesn't look like it. So I think with that, we'll dive straight into the meat. So let's talk about convergence. So what is it? So I think this diagram on the right is a good explanation. Essentially, what convergence is during or after the excavation process of the tunnel face will move or deform. Right, so it'll change shape slightly. I'm not talking about it all of a sudden buckles in and that circle becomes a square, but really slight movements that cause it to change and deform. And this is what we call convergence, and it's typically a result of the geology of the surrounding tunnel structure. So what type of rock, is it clay, or what type of soil, for instance, and the stress and the forces that surrounding soil puts on the structure of the tunnel. And it also has to do with the tunnel shape. So what kind of tunnel shape? Are we have more of a D or a horseshoe type shape, or is it more of a TBM, like a circular shape? And so to monitor convergence, we take repeated measurements of the tunnel shape position. So measurements of the tunnel shape relative to itself. So in this case, each of those blue lines are essentially measurements from one portion of the shape to the other to understand how it's moving in or out. Most of the time, it's always moving in. And this data will show the displacement within the tunnel.
So now you may be wondering, why do you need to measure tunnel convergence? Well, most importantly, the amount that a tunnel deforms could pose a safety risk to your on-site workers, as well as a stability risk to your project. So if you have too much convergence, you run the risk of having your project collapse. And if you have too little convergence, your final design might not fit properly. This would be evident in cases of prefabrication, where your tunnel design is created prior to finishing the boring or excavation process. Another reason to measure tunnel convergence is to monitor the conditions of existing tunnels. So you might want to verify the stability or the structural integrity due to external factors, or maybe just look at how it performs over the long term. Basically, tunnel convergence can kind of serve as a form of risk detection, either by detecting possible geohazards, or for example, you might be building a new tunnel beside your existing tunnel. It might be useful to kind of monitor how that construction is affecting your current existing tunnel.
Exactly. All right. So with that, we've kind of explained what is convergence monitoring and why do you do it. So what I'm going to do next is we're going to throw up a poll right now. So you should all see on your screen a poll that will pop up, and I'll launch it right now. All right. So with that poll, feel free. There's 4 options. There probably could be more options, but the idea is to get an idea from the crowd here today. If you're doing convergence monitoring, you're working on tunnel or mine projects, what are you using today to do that? And then if you're not doing it as well, of course. So for those of you who are just tuning in to find out a little bit more. So we'll leave that up there for a few more seconds to capture. It looks like we're getting quite a few people. Thank you for voting. Appreciate it, everyone. Cool. All right, we'll give it a little bit more. It looks like we've got pretty much 2 responses for the two options that are coming out across the board. There's it looks like the laser is coming in with a few so far. All right, so we got a good chunk of people who voted. I'm going to close that now, I think. All right. So you should be able to see the poll results. So it looks like a good chunk of people here aren't performing convergence monitoring right now. No worries there. I'm glad you're here at the webinar, so we can give you a little bit more information on how that works, and maybe you'll be doing it in the future. But in terms of some of the technologies that others might have been using in the past, looks like resounding, the majority is total station or optical measurements. And that's great, because that's what our focus is going to be today. But it's good to see there's a 10% of you are also using extensometers to do monitoring. So it's also a really useful technology. So I think with that leads into our next part here, where we're going to look at the types of technology you use to measure convergence. So first and foremost, I think this is probably one of the more conventional ways that's been done or used to measure convergence for many years. And we call that extensometer, a tape extensometer, another term. But essentially, you're connecting 2 portions of the tunnel, as you see on the image on the right-hand side, and measuring in that tape, that object there, how it's changing over time. Now, you usually get a high level accuracy out of this and a fair amount of precision. The challenge is it's typically not an automated process. You usually have to send somebody in to read those observations every so often to see what the convergence is. It's fairly low cost to install and medium range in terms of time to go out, install, and collect the data. And then in office processing, it's fairly easy. You're looking at very single values, but you have to do a lot of that processing yourselves, whether that's in a spreadsheet or some kind of software. Now, one of the growing technologies to measure convergence, and potentially we'll talk about this in a future webinar, is using wireless distance meters, wireless extensometers, where instead of having what I would think of as an invasive approach, like we saw in the previous one, where you actually have to have a physical object kind of covering the tunnel cavity, and it kind of can get in the way of equipment, can get damaged. Using a laser distance meter, for one, you don't have to have that large object, but you have a little laser, and it's measuring, it's very similar data you're getting that single distance between two parts of the tunnel, but you're also able to automate that. So using the wireless capabilities of the device, you're able to automate it and install those sensors, and then the cost to collect and go out and get the data is very low because you don't actually have to visit site. It might be a little bit higher to install and the time to install, but once you have it there for long term, it's very hands-off. And of course, that processing is done automatically as the data is streamed into whatever software you're using. We're seeing more and more 3D laser scanning being used to measure convergence. You get a high fidelity of data. You get a capture of the entire tunnel surface. So it can be used for a multitude of things, not just convergence. You can use it for as-builting, you can use it for a variety of other things. The challenge is it's not quite automated process yet, and it's very time intensive, especially on the office side, to process that scan data. Usually you have to georeference it. You might have to stitch multiple point clouds together and then extract. If you're looking for discrete points for convergence, you have to extract that out. And today, which is what we're going to primarily focus on, is the robotic total station workflow, where you're getting high level accuracy and precision. There are ways to automate it, and then there's ways to use it in a more manual data collection fashion. So looks like I've mixed up the table a bit here, but the cost to install and collect is roughly medium. You usually don't have to install much other than the target infrastructure, so your prisms and your targets. But aside from that, it's about going out to the field on that repeated basis, whether it's once a day, a week, a month, and collecting the data. And then there's some office processing usually that goes on there. And today we're going to go over how you can really streamline that workflow and reduce some of these costs and time to collect and processing. Now, the one last method that I'd like to cover is automated total stations. So this is where your total station lives on site permanently. You install it, you give it power, give it communications, and you're giving that same level of repeatability and accuracy, but you don't have to visit site very often to get the data. Because it's automated, it's coming to whatever software you're using in the office automatically. So the time and the cost to collect is very low. So you might have an upfront higher cost to install the sensor and get all the infrastructure ready. But long term, the data capture is much more efficient and the processing much more efficient. So today we're going to focus on the convergence monitoring, and I'll let Nicole talk here a bit about the challenges and opportunities.
Thanks, Riley. So for some challenges, the longest part of the workflow would be manually calculating your data and its movements. So with TA and TBC, we have automated displacement calculations and reporting. The next challenge would be data capture and delivery time. So like Riley just said, we will be focusing on robotic total stations in this webinar, but basically that kind of gives us a more streamlined data collection in the field. You'll see this more when Riley performs his demo with TA. And finally, another challenge would be managing large data sets. So depending on how often you collect convergence data, this could be hourly, daily, weekly, monthly, you will have a lot of data. So all that data will be centralized in TBC, and again, you won't have a need for spreadsheets. So yeah, those are the benefits of using Trimble for convergence monitoring.
Excellent, thank you, Nicole. All right, so what we're going to cover today is we're going to cover all things workflow using robotic total station to capture convergence data, process, and get out the reports. So really how this starts is installing the target infrastructure on site. So going out, installing prisms usually, or even reflective targets in the tunnel structure, usually screwing in a bolt of some sort into the tunnel structure itself, and mounting a prism on it. And usually you have the project dictates how many points and how often along the tunnel axes you need to monitor convergence, and that dictates how many prisms you'll need. Next, you use the robotic total station and some field software, and in this case, we're going to cover Trimble Access monitoring, and you're going to use that to collect the data on a reoccurring basis, whether that's hourly, daily, weekly, monthly, whatever the project specification requires. And then we're going to import all that data into the office, into Trimble Business Center, and that's where we're going to manage all of that convergence data and do any processing, any QC work we need to do, and then the final step, creating those convergence reports for tracking and analysis of movement in the tunnel. So with that, we're going to switch over to the demonstration. Right. Give me 1 second, everyone. So we're going to start on the field portion. So we're going to switch over to Trimble Access monitoring. So here I have a total station set up, and I can probably switch it so everyone can see. I'll just give a little example. So I have an SX12 here, and we're going to be using that to do convergence monitoring. So let's start it off. So back in Trimble Access, I have some targets defined here. Each of these MP points is a monitoring point. And so how Trimble Access monitoring works is you can measure existing points on site and then monitor those in a continuous way. Well, you could also import a file. So if you have a previous set of rounds, maybe from you measured a week ago, and you want to import that previous set of targets, you can import those and measure them again. So I've gone ahead and I've already set up my points. I have a few different monitoring points. And what I'm going to do is I'm going to measure to these points. So I have here a list of monitoring points. So in this case, usually in a tunnel, you'd be using a resection. In this case, I've just got a standard backsite setup. You can use both in Trimble Access monitoring. It's up to you on what you need. In this case, we're using a single backsite, which I've got defined here. And then I've got 5 different monitoring points and prisms with their respective target heights. And like I said, in the bottom, you could import a CSV file of a previous round you measured, or even if in the office you've defined a set of targets that you need to go out and measure to, you can import that data here. You can also add targets if you want. If I have additional prisms while I'm in the field, I can add additional ones, and I can edit those as well. So in this case, I can go in, I can change the prism type, a variety of prisms, I can change the target height, I can change the working mode. For example, if I'm using a long-range fine lock and I'm measuring distances of 1-2 kilometers, I can change that in working mode here and make sure that even if the target is farther away, I can use the proper working mode. All right, so we've got all that there. So how do we monitor? Well, we're going to go next, and this is where we define how many epochs we want to measure. So you can go 1 to 10, or you can also set to infinity, which will mean that the total station will continue to measure all of the targets you define until you tell it to stop. So in this case, we're just going to measure a couple just to show you how it works and that workflow. So let's go with 2. I can also define quite a few options. If I go to the options menu, I can change a variety of things, right? I can change the idle time between successive rounds. So for example, maybe I'm sitting on site and they're driving a pile into a structure, and I want to measure the structures around, and maybe I need to collect a measurement every 10 or 15 minutes. I can set this up so that the total station measures every 15 minutes instead of continuously measures. So variety of factors there. You can also change how many measurements, right? If I want to do multiple faces, if I want to do phase 1, phase 2, or I want to change that phase 1, phase 2 order, I can do that here. I can define how many sets and rounds as well. So if I'm doing a complex network, or I'm trying to get high precision data, I can change that settings here. There's also a variety of other things that we won't get into in too much detail here, but things like repeating missing targets, skipping obstructed measurements, and so forth. All right, so we have that, and we'll go back to the monitoring screen. So I've got my epoch set up, and I'm going to hit next. And of course, you can put in your temperature and pressure corrections, and then you'll see that it's starting now to monitor. And we'll give it a few seconds and we'll see that here and the progress, it's telling me what's going on. Right now it's measuring the backside point. I can also click this drop-down menu and switch between different things. You'll see on the left-hand side in the map view, the red dotted line is where the total station is currently pointing. And so if I switch here on the right-hand side to deltas, I can see any movement that's occurring in those targets as we're measuring them. So it's going through, it's measuring those targets. Obviously, I'm in a nice stable room, so I'm not getting a lot of movement, but it's going to go through and measure all those targets. I can also look at things like the residuals and any of my backside or resection points. Looks like I have a pretty solid backside point. And I can see if there's any warnings. So for example, if I have a tolerance set up that's maybe 3 centimeters, that would flag if any points are measured displacement over 3 centimeters, it would show that here. So this is all in real time as the data is being captured. And so I'll flip on the webcam here just to show you as the instrument's measuring. I'm going to go move one of the targets just to show you what happens when we move. All right, so it's starting the next round of measurements. So we should see I've moved one of these points. I believe it's monitoring point 1. So we should see it flag the displacement as being more than a few milliamps, so about 35 millimeters. So right there, I'm seeing in real time any movement that's happening on site. And if it's out of my warnings, that would flip up here. It looks like my warnings are set up higher, so it's not showing there. And go back to the deltas. And so it'll keep continuing to measure. All right, and so when that's finished measuring, we'll let it keep going, but while it's measuring, we can go look at the report options. So we can actually see dive down into the displacements and things. So if I go in here, I can see all of the epochs I've measured so far. So if I click on 2 of those and press next, I can see any of the displacement. Obviously my displacements are pretty much 0 because there was not really any movement. But as I scroll through, I can see there's a little bit. And if we move to the last one, there's our point that I moved, roughly around 40 millimeters. And so I can dive into those displacements to more detail. All right. So with that, we finished our monitoring round. If I want to get some more detailed reports, there is a report section, and there's a variety of formats here and a variety of ways you can get that data out. And then if you're importing it into TBC, you can take the job file or the JXL file and import that data directly into Trimble Business Center. So we've collected the data, and now what we're going to do is we're going to switch it over to Nicole. And Nicole is going to take us through, the TBC workflow once we've collected the data. So I'm going to switch screen over to you now, Nicole.
Awesome, thanks for that demo, Riley. Okay, I'll share my screen.
Cool. I can see TBC. So you're
Okay,
good to go.
Awesome. Sounds good, thanks. So for the TBC part of this demo, we'll first cover creating a monitoring project on Trimble Connect through TBC. Trimble Connect is basically a cloud-based tool that will store our monitoring data, and to use it, we will have to log into our TID accounts. I'll show that in a bit, but after doing that, we can then sync our epochs, which contain convergence data. This will be done using the assign tunnel convergence points command, which is here in the tunneling ribbon. Assign tunnel points and assign convergence points here. For the sake of this demo, I'll be syncing up 2 epochs. Finally, I'll use the new tunnel convergence report command, which is here at the end of the tunneling ribbon. And this will generate my displacement summaries. That being said, let's get started. So here I have a tunneling project open in TBC 552. And as you can see, I do have a tunnel mesh here, so you can kind of see the shape of my tunnel. And I also have some points imported. So with the 3D view, you can kind of see how these points rest along the shape. This will actually be more, I guess, intuitive with the tunnel view, which I will touch on a bit later. But for now, we don't need the tunnel mesh, so I'll be turning that off. Going back to the plan view here and switching to my Project Explorer, I wanted to show what I brought into this project. So here I imported a job file. You'll see that it has a date of 7/11/2020, and my project is also named accordingly, just to kind of better keep track of my epochs. This brought in my convergence points, and I also brought in this TXL file, which imported in my alignment, my corridor, my tunnel, and my tunnel shape. With our monitoring project, unfortunately, it only really saves our convergence points, so we will have to import this TXL every time we want to sync up a new epoch. I mentioned just now that you will have to log into your TID account, so you can do that by selecting this icon here in the top right corner and selecting Log into Trimble Identity. That will bring up this web page here where you would enter in your email. And I already logged in earlier today, but if you haven't logged in a while, you might have to go through like a two-factor authentication. But as you can see, I'm logged in now, so that looks good to me. And we can get started with creating our monitoring project now. So because I know that I need to create one, I can go straight to the monitoring tab up here in the ribbon and select Assign Monitoring Project. However, let's say you're new to convergence monitoring, or maybe you forgot that you have to assign a monitoring project first. If you go to the tunneling command over here, Assign Tunnel Convergence Points, this pop-up dialog here will tell you that you need to assign a monitoring project first and asks you if you want to go to that command now. I will say yes. And when I do that, you'll see that the command changed from assigning convergence points to assigning a monitoring project. And just now you saw that it was syncing up. It was just grabbing my Trimble Connect projects, which you can see here in the dropdown. But for the sake of this demo, I do want to create a new project, so I'll select that first option there. And let's give this a name. So let's call this PH Demo-September. And I'll hit Create Project. And for the monitoring epoch, you'll notice that the job file does contain a date, as I mentioned before. So I will match that up. So let's make this 7/11/2020. My job file also contains a time, so I'll change this to 9:53. And I'll hit save at the bottom here. So right now it's just creating my monitoring project. And if I go to the Trimble Connect webpage, you'll see that I do have some previous projects here. Here it shows up, PH Demo-September, and this is where you can share amongst your colleagues, so you can invite people to this project this way. While this is also syncing up, I wanted to kind of touch on what we're doing. So we are syncing up the first epoch in our project. This epoch is known as Epoch 0 or our baseline epoch. That's because there's currently no previous data, so there's nothing to really compare these points to. We'll see this more in a bit, but this will act as our first epoch, so future epochs will be compared to this one here. So now that's finished syncing up, you'll see that we have a new node in the Project Explorer called Monitoring Project PH Demo-September. It's currently empty, so we'll fix that by adding some convergence points now. Going back to the right here, you'll see that the command switched from assigning a monitoring project back to assigning tunnel convergence points. So looking at the tunnel, I only have one, so I'll leave it at that. For the selection method, you have two options, specific station and station interval. Specific station is good for selecting points and manually assigning them to stations that you know you want to assign them to, but station interval is a faster way to assign points. It basically takes your selected points and assigns them to stations based on proximity. So for now, I'll be using station interval, but we will be touching back on specific station in a bit. So for the beginning and end stations, I'll leave that as is. Those are just the beginning and end values of my alignment here. And for points selected, I will expand my points node in the Project Explorer. And I will note that you can select points through your plan view like this by clicking and dragging, but since I know that not all of these are convergence points, I'll be selecting them through my Project Explorer. So here I will use the shift click method to select all of my PC points because I know that those are my convergence points, and I will hit add. And here you'll see that the convergence points table kind of gets populated with stations, and if you expand these nodes, you'll see how many points are assigned to the station as well as what those points are. For the sake of this demo, I do want to also show that you can delete points that you might have added by accident or that you no longer need. So zooming in here to the plan view, let's select these 2 PT points here. Oops. There we go. And I think they'll show up under station 18. So you'll see that here as well. That's looking good to me right now, so I'll just simply hit apply. And this will ask me if I want to save my project to continue. I will say yes. So it brings up this synchronization progress bar. And right now it's just taking the points that I selected and adding it to our monitoring project.
Hey, Nicole, question for you. Most of the time convergence monitoring is done with total station data, but if let's say I'm not monitoring a tunnel, maybe I'm monitoring above the tunnel, like the road above the tunnel, and I'm using like a level, or maybe I'm using GNSS. Can I use other data with the TBC monitoring functions?
Yeah, for sure. Any point data should work.
Perfect. Thank you.
Thanks for the question, Riley. So now that that's finished syncing up, you'll see that we can now drop down this node here. So I will right click and hit expand. And underneath this monitoring project node, we'll now see the tunnel, all our stations, and what points are again assigned to those stations. As I mentioned earlier, I did want to show that you can delete points that you might have added by accident or no longer need. So that's those 2 PT points here. We'll see them under station 18. So what I want to do is to select them with shift click, either in the plan view or the project explorer. I think right now, since we don't have any vectors, which we'll see later, it's easiest to select it in our project explorer. But I'll select them, right click, and you'll see there are 3 options here. So you can delete this from all epochs, delete it from the current epoch, or you can unlink the convergence points from the station. Because I know that these are not convergence points at all, I want to get rid of them entirely. I can select either the first or second option since I only have 1 epoch in my project right now. I'll select the first option to delete it, and we'll get this pop-up dialog here asking me if I want to do this because it cannot be undone. I will say okay. And right when I do that, you'll see that station 18 goes red along with the project node itself. That's to be expected. It basically means that there was a change in the project that hasn't been synced up to our monitoring cloud project yet. We can do that by going to the monitoring tab up here and selecting the sync monitoring project command here. This will again ask me if I want to save the project to continue, and I'll actually say no because there's one more thing I wanted to do first. So touching back on that third option of unlinking a point from a station, let's do that with station 11 containing PC34A. Let's say, for example, we want to move PC34A from station 11 to station 10. To do that, I can select PC34A, right click, and now we'll use that third option of unlinking it from the station. And similarly, you'll see that station 11 goes red as well, and you might notice that there's a new node here called monitoring points that now houses PC34A. This will make it easier to reassign this point to another station, which we will be doing now.
I think this is pretty cool because back to my previous question, you could have convergence data under your monitoring objects node, but then you could have monitoring data for other parts of the project, like you're showing here, like where PC34A would be.
So now going back to the assign tunnel convergence points command that I still have open on the right, I now want to change the station interval method to specific station. And like I said earlier, we want to move PC34A to another station. So let's move it to station 10 to be with the other PC34 points. I will change the station to 10. Oops. And for points selected, I will go to select it through the Project Explorer here. And I will also expand these nodes just so you can see what's going on. So since it's already been unlinked from station 11, it currently has no points, and station 10 still has only 2 points. So once I hit add, you'll see that PC34A gets added immediately. I think that is it for changes that I want to make right now in Epoch 0. So let's go ahead and sync our monitoring project again, sorry. I'll hit apply and say yes. You can also hit OK, or again, use the sync monitoring project command up in the ribbon here. So right now, You see the progress bar again. It's just taking the changes that I just made and syncing that up to our cloud project, and we would expect these changes to persist in future epochs.
Hey, Nicole, I've got a question if you're ready to answer it. So the question is, what's the intent behind grouping monitoring points by station?
So I was going to show this in our next epoch, but I could definitely show that now. If I go to the tunnels tab here and select tunnel view, let me move this to our previous group so it's a bit bigger. This convergence tab was added to 550, so if I use these arrows to toggle between stations here, you'll kind of see that these points rest along the tunnel shape. So that's why you would want to group it by station, so you can kind of see that they fall along the shape properly, and you can kind of monitor their movement this way. This will be a bit more apparent once we sync our second epoch. If there are no other questions, I think we can move on to our next epoch. Sorry, I guess before doing that, you'll see after syncing our project, all the text goes from red back to black. That means that it's synced properly, and we'll see PC34A now shows up under station 10. I think now we can go to our second epoch, so I already have that window open here. Looking at the job file, you'll see that this is from the next day, so 7/12/2020. And you can see that I also brought in that same TXL file to bring in my alignment, corridor, tunnel, and shape. I'm still logged into my TAD account, so we can go ahead and go straight to assigning our monitoring project. And again, if you forget that you need to do this, if you select the convergence points command again, that'll remind you of that pop-up dialog. So in this dropdown, I want to select the project that I created earlier. So let's scroll down to, I think it was PH Demo-September here. And again, I want to change this monitoring epoch to match my job file's date. So 7/12/2020. And let's change the time to be 10:34. I'll hit save. And right now it's just synchronizing and bringing in that data from our previous epoch. So as you can see, we have that node show up in our Project Explorer again. And if I expand this, we'll see all of our stations as well as the points again. However, if you look, there's a little tiny asterisk beside our points. So if you click on that, in the properties pane, you'll see that it's called a historical monitoring point, and it doesn't have any displacement data. This is because our points do not exist in this project yet, so this is just indicating that these points have been synced up in the past. To fix this, we'll need to assign tunnel convergence points here too. Let's go ahead and do that by going to the tunneling command over here in the tunnels ribbon. So here, without even doing anything, you'll notice that my table is already populated. Station 11 still has 0 points attached to it, while Station 10 has PC34A added. So again, when we synchronized this up in our previous epoch, our monitoring project does remember that, and it can show that in our next epoch.
So to make sure I understand, Nicole, like when you open a second TBC project or third or fourth, any subsequent project, it remembers the point ID from your reference epoch. So it already selects those points for you automatically.
Yep, exactly.
Gotcha. Cool.
And if I wanted to, I could add more points, but for the sake of this demo, I won't be doing that. I will simply hit apply, and this will ask me again to sync up my monitoring project. You'll see that everything in my Project Explorer goes red. It's again just syncing up and grabbing that data to bring into this project here.
So while that's syncing, there was a question that came in from Mateo that I answered in chat, but I think it's good to answer out loud for everyone. So in TBC, can I have both convergence points and monitoring points in the same project? And yes, the answer is yes to that question. So for example, if you had some leveling data where you were checking settlement monitoring, you could have that in the same project as your convergence data in the tunnel.
Thanks for answering that question, Riley. So now that that's finishing up, we'll see that immediately there are some vectors in our plan view. Some are green, some are yellow. We'll kind of look at that in a second, but looking at our Project Explorer, you'll notice that those asterisks are gone, and if we click on a point now, it'll revert back to convergence point. Looking at the displacements here in the properties pane, you'll see that we now have values. So again, in our previous epoch, which was our epoch 0 or our baseline epoch, these would have been all zeroed out because it had no data to compare to. So now that we're syncing our second one, we now have these displacement values. You'll also see that we have station and alarm thresholds. We'll play around with that also, just to kind of show that the report can highlight different threshold values. With that being said, I think we can get right into it. So I again want to open up the tunnel view here. And I will bring this into the previous tab to make it a bit bigger. And I'll select the convergence tab at the bottom here. So now that I have this tab open, I wanted to talk about it a bit more. So if you want to select the assign tunnel convergence points command again, you can also do that from this tunnel view tab here. So this command box is also available here as well. I'll close it since we don't need it right now. And you'll notice that these points do have different shapes. You can play around with that by selecting this gear icon at the bottom here, which brings up our project settings and brings you straight to tunnel view. Here you can choose to show or hide your convergence points and their IDs. But if you go to the node below, which is convergence point, this is where you can change your markers as well as your colors.
Hey, Nicole, sorry to interrupt you. I just think this is a good question for where you're at right now. So Gary asked, are the vectors, so the displacement vectors, are they scaled up or are they scaled at all? I guess is the question.
They are scaled. So if you have one point that is just crazy out of tolerance, like maybe like 7 meters or something, that will make all of the vectors, all of the other vectors a bit harder to see because that displacement is just so large. So it is scaled appropriately.
I believe you can change that somewhere in the settings, right?
I'm not too sure. Let me take a quick look. If I can't find it now, I can get back to you on that.
Yeah, I believe it's,
yeah, this
somewhere.
one here, maximum displacement arrow length.
Yeah. So Gary, to answer your question, yes, they are scaled, and you can change that scaling to depending on what your project needs are, what kind of movement you're looking for and stuff in the project settings.
Yeah, awesome question. Thanks, Gary. I won't be making any changes right now, so I'll just hit cancel, and let's get to changing our vectors. So the reason why I want to do that is to again kind of show that the convergence report can highlight different out of tolerance values. So for station 10 here, let's go ahead and change, let's say PC34A to be green. PC34B is already yellow, so I'll leave it at that. And let's make PC34C red. So looking at these delta displacement values here, it looks like the offset value, is the largest. So I'll play around with those warning and alarm thresholds. For PC34A, to make this green, it's currently yellow, so it means that one of the displacements is greater than the warning thresholds, but less than the alarm thresholds. So that seems to be, again, the offset value. So to make this green, the warning will have to be greater than the delta displacement. So let's make this 0.005. And right when I do that, you'll see that the vector in the tunnel view changes from yellow to green. This also reflects in the plan view as well. And if you look at the Project Explorer, it goes red again, indicating that there was a change. And looking at the offset warning here, you'll see that it changed from 0.003 to 0.005 as well. Going back to my plan view now, PC34B is again already yellow, but I do want to change another warning threshold just to make another displacement go off in yellow. I'm only doing this to kind of show that the report can highlight multiple columns for one point. So looking at the delta displacements, it looks like the station value is the next highest one. So let's change the station warning to be 0.002. So again, no changes because it was already yellow, but we will see that in the report in a second. Finally, for PC34C, to make this red, it looks like we have to change again the offset. So this time I'll be changing the alarm thresholds that it is less than our delta value. Our delta value is 0.005, so I'll change the alarm threshold to be 0.004. And again, we see that immediate color change in the tunnel view as well as in the plan view here. All three of those points for station 10 are highlighted because we changed the warning and alarm thresholds, and we'll have to sync that up. So I'll go ahead and do that now. Selecting the monitoring tab up here in the ribbon and going to the sync monitoring project command here and saying yes.
Hey, Nicole, while that is syncing, looks like there's a lot of people paying attention because you got some good questions. Appreciate it, everyone. So, question from Edwin. Okay, assuming, let's say on the site there was mixed total station brands being used to collect the data, is it possible to merge that data in TBC? Is there a specific format required? So I think I'll answer this one, Nicole, if you don't mind. So Edwin, so the short answer is yes. You can bring, how the monitoring module works is it's all about the point coordinate. So even if it's a simple like ASCII file or CSV file, you could bring that data in and use it for monitoring. For more like raw database formats, there are a few different formats from different non-Trimble manufacturers that are supported in TBC. Off the top of my head, I don't remember what they all are, but they're definitely in the help file in TBC, so you can find that there. All right, I think I'll save the next question. Nicole, I'll let you keep going with your demo before we answer some more.
Okay, sounds good. Thanks, Riley. So now that that's finished syncing up, you'll see that the red text went back to black again, and in the properties pane, we'll see that the synchronization status is now synchronized. And I did just show changing these values in the tunnel view here, but I also wanted to note that you can also use the properties pane to change those values. Using the properties pane is actually probably better if you want to change multiple different point values at once. So in the tunnel view, you'll probably realize that I could only change one point at a time, but with the properties pane, I can select multiple points at once. So maybe all of these and then change them to all, change them accordingly this way. For now, I'll leave it as is, and I want to jump straight into the conversions report now. So going back to the tunnels tab here and selecting that conversions report command at the very end of the ribbon. Before doing this, I do want to note that you can create your own custom report with these two commands here, but for the sake of this demo, I'll be using just the base tunnel conversions report command. So I only have one shape in my project, that's fine with me. Here we can see the convergence point stations and how many are assigned to each one. You don't have that drop down as we did in our other command with the assigning tunnel convergence points, but that's fine. I don't need to see them right now. And for begin and end station, it's again just taking the start and end of my alignment. Let's say for my end station, I want to end it actually here. So you can also input the value manually with your keyboard. So looks like we'll be ending at station 51. I can also specify a time period if I want to, but I only have 2 epochs in my project, so I'll leave that unchecked. Here I have an option to change my vector exaggeration factor. This will make the vectors in your report a bit more visible, so let's up this to 200. For image scaling, I only have one shape, so I'll leave the first option selected, which is to use the same scale for all stations. And now I'll hit apply. And this will just bring up my report in Microsoft Word.
Hey, Nicole, just for my clarification, the vector exaggeration, is that for the displacement vectors? So if I have really small movements, like a few millimeters, if I want to see bigger vectors just so they're more prominent, that's what I would change?
Yep, exactly. Thanks for the question. So here our report opens up in Microsoft Word. The first page is just an overview of your project, so you can add a project title if you want. The reported date is just today's date, the date that it was generated. We have our tunnel name, and the report start and end dates are just our epoch dates, so 7/11/2020 to 7/12/2020. Here we have our number of stations, which is 7. So if I go to the next page, we have our summary, and you'll see that there were 7 stations here. And if you recall, I did change the end station to be like 54, so it ends us at 51. In the next column here, we have our points that are associated with each station. So for station 10, we have 34A, B, C. Now you may be wondering, why is this in reverse order, as in it's in CBA? this is actually totally fine, because if I go to the previous page, and if we look at this diagram here, how the report chooses to list points is by starting in the middle where your alignment would be, and then moving clockwise. So if we do that here, we'll first meet PC34C, and then B, and then A. So that's totally fine. Next, we have the number of epochs that these points appear in. So it looks like all of these points appeared in both epochs that I synced up. That makes sense because I didn't add or remove any points in my second epoch. That looks good to me, so I'll scroll down to the next page now. And here we have our vector diagram for station 10, and you'll see that the vector exaggeration factor is 200. So like Riley was asking earlier, this vector exaggeration factor is just to make these little vectors here a bit more visible, because these are really small movements. So that's why we made it 200, just to make them a bit more visible in the report. So here we have the tunnel plan view, the tunnel cross-section view, and the tunnel profile view, as well as a little legend so you can see what's what. So this little vector here is showing the direction from the first epoch to the last one. So it started here and ended here. Moving on to the next page here, we have our displacement chart. So this is showing our displacements for the station offset and vertical. And this looks a bit funny because I only have 2 epochs, but I do have a report with a few more epochs that I will show in a second. Moving to the next page here, we have our displacement detail. So this is again in reverse order of CBA, but if you recall, I made PC34A green. So down here, nothing is highlighted because all of our displacement values are within acceptable thresholds. So it didn't go over any of our warning or alarm thresholds. For PC34B, you'll recall that it was already yellow, and what I did was I went and changed the station warning threshold to be less than our displacement station. So I wanted to show that it can highlight multiple different columns for one point. That's what we're seeing here, so that looks good to me. And finally, for PC34C, I made this one red, so I made the alarm threshold less than the displacement value, and that's highlighting appropriately as well. Next, we have our distance analysis chart, which shows the movement between the points from each other. It's a bit more intuitive to look at the distance analysis detail though, so I'll scroll down a bit. And here we can see the distance movement between PC34A to B, A to C, and B to C. So for example, PC34A to B, looks like these distances are the same, so our distance displacement here is all zeroed out. That looks really good. For the next table, we'll see that there was a tiny bit of movement here from A to C, so we see that difference here as well. Scrolling down to the next page here, it starts all over again, but with the next station, which is station 19. Before ending this off, I do want to note that if you want to see more or less decimal places in your report, you can go to TBC here, go into your project settings, and change your units for distance to have more or less decimal precision. That should conclude my portion of the demo. I'll send this back to Riley so that he can finish us off.
Sure. So before we go on, we're coming to the end, but there was another question I wanted to get to. It was a really good one. Search here. Oh yeah. Okay. So how to determine if the monitoring stations themselves are moving? So where the total station is located, or maybe your control points, how they're moving. So there's a couple ways to do that. We didn't really get into them today, but that's a great question. So what I'd recommend in TBC is using the QC tools, things like the point computation report and some of the other tools. You can even use the adjustment tool to an extent to help diagnose where you have movement, basically telling you if maybe your resection is poor because one of those resection stations is moving. So you can use a variety of different computation tools in TBC to do that. So I'll keep that in mind for next time, and maybe we'll in a future webinar we'll get a little bit more into how you can do that in TBC. So great question, appreciate it. And just looking to see if there's any other new ones that I've missed. Doesn't look like it so far. So I'm going to switch back and show my screen here. All right, so just to wrap up the demonstration. So once again, what did we cover today? So we started by talking about installing the monitoring targets. I'm not going to drill a hole into this office here to install the targets, but I did have some prisms set up this morning, but we used Trimble Access monitoring and the SX12 to measure those points. So we brought in some coordinates, we measured those prisms and got some movement data. And then in TBC, Nicole ran us through how you import that data, how you link it to a tunnel design, and then generate the convergence reports and view that different information as well as your warnings and your alarms. All right, so with that, I would like to move into resources and next steps. So for any of you who want some more information, you're just curious about maybe some of the tunneling stuff on the Trimble side of things. So we do have a website, tunneling.trimble.com, tons of great information there. And I urge you all to go take a look. Let us know what you think. There's some good information on different parts of a tunnel project, whether you're more focused on TBM projects, maybe you're doing more sequential excavation type projects, maybe you're focused on doing monitoring. A variety of information there. And then for any feature we have in TBC and Trimble Access, both monitoring and tunneling, there's a variety of good information on YouTube. So you can go onto YouTube, Trimble Tunneling, and find pretty much a video for every workflow. There's tons of them there. I think we're around 60 videos or something like that, maybe even more. And of course, if you're using TBC and you want to play around with the tools, on our Trimble website, there is a sample data sets page, so you can go on there and download a few sample data sets and actually see how that data works in TBC before you even actually go out and collect your own. So great way to demo some of the features in TBC. In terms of just general TBC resources, of course, there's a lot of great stuff out there. There's the TBC website, and from there, that's basically a kickoff point for a variety of great things, everything from the YouTube page, which there's that YouTube page has been around forever and has got hundreds of videos on it. If I don't know something in TBC, that's where I always go to learn it. Of course, there's also more sample data sets, and there's a new e-learning new e-learning modules for TBC that are self-paced online learning modules that you can go on and kind of learn different portions of TBC and go through that. So you can find that in the PDF that's attached, or links to that, I mean, attached in the handout section of GoToWebinar. And I urge all of you, especially if you're just getting into TBC and learning it, that's a great way to learn the features. And then next month, of course, this TBC Power Hour, if you're a regular attendee, you know this, but if not, if you're a first timer, we hold TBC Power Hours every month, usually the last Wednesday of every month, depending on the month. And next month, there's going to be a great one on using more in terms of aerial data and using TBC combined with scan and aerial data to generate deliverables, especially for things like real property reports, ALTAs, NSPS surveys, that kind of information. So I think that's going to be a great webinar, so definitely stay tuned. There's going to be a registration link for that that'll come up quite soon. You'll probably all see that in an email. If not, you can always find that on the webinar page on the website. So a lot of great stuff there. And I think with that, brings us back to the end of the presentation. So I'm just going to take a look, see if there's any questions that have popped up as I've been talking. We'll sit here for a few minutes. If any of you do have questions, by all means, type them in and we'll answer them. If not, I urge you all, feel free to reach out to me. My email address is there, riley_smith@trimble.com, or connect with me on LinkedIn. I always love to hear about different monitoring, tunneling projects that you're working on. So feel free to connect with me, and I'm happy to chat more if any of you would like to. If not, let's just take a look at the questions. Didn't see any new ones pop in. Give it a few more seconds. All right. Well, it doesn't look like any more questions are coming in, which is okay. As I mentioned, this is recorded, so you will receive a link probably within the next day of the recording. And from there, if over the next day or week you think of some other questions, feel free to reach out to me, and I'm happy to chat about tunneling. In the meantime, I want to say thank you to Nicole for a fantastic demonstration of the TBC convergence monitoring workflow. That was great. I learned tons from it, so I'm sure everyone else on the call learned quite a bit as well.
Thank you, Riley. I really enjoyed this, and thanks for your demo as well.
Awesome. All right, with that, everyone, I think we will call this webinar done. Appreciate you all joining, and we will look forward to seeing you all in next month's webinar. And until then, take care and stay safe.